Welcome everybody to my session regarding OpenJDK and Eclipse Adoptium and an update what happened in both projects, especially with the release of Java 17, for example. I'm Hendrik Ebbers. I work at Karakun and I live in Dortmund in Germany. And I'm a part of, or I was part of the Adopt OpenJDK team and technical steering committee. And today I am part of the Adoptium technical steering committee at Eclipse. And we present Karakun there as a strategic partner regarding the future of Eclipse Adoptium and Open Java in general. And today I would like to talk about some topics. First of all, I would like to give an introduction of the OpenJDK and what the OpenJDK exactly is. And based on this, I would like to talk about the Java release model, why most of you already know the new release model that was introduced with Java 9. But especially with the release of Java 17, there are some new things regarding the release model. Then we will have a quite fast overview of features that, or of new features in Java as a language and the runtime between Java 11 and Java 17. And at the end, we will have a look at different distributions on and build of the OpenJDK, and here especially at Eclipse Adoptium and what we are doing in this project. Okay, let's start with the OpenJDK. So the OpenJDK is the open source repository of the Java runtime and the Java language. And in general, Java has been open sourced in 2006 by Sun Microsystems. And then some years later, Oracle took over Sun Microsystems, but they continued to work in the OpenJDK and contribute to the OpenJDK and based on this, keep Java as a runtime and as a language open. The OpenJDK, or the main entry point to the OpenJDK, is the OpenJDK web page. And when you go to this web page, there's quite a lot of points, especially on the left in the menu. And at the beginning, you really have no idea what to find there and how all this is structured. It's quite complex. But at the end, when you go deeper into it, you can in general define the OpenJDK next to the sources that are hosted in 4 different parts that you can find on the website. First of all, the website is structured in so-called OpenJDK groups and OpenJDK projects. OpenJDK group is a group that has some members, so a group of people that are interested in a specific topic, like, for example, hotspot or the core Java libraries, or, for example, the 2D graphics that are used in, for example, HWT or Swing, things like that. And on the other hand, you have projects. OpenJFX is a project, for example. Then we have the general JDK project. And the groups and the people within the groups contribute to different projects. Here you can see, for example, I think it makes sense that the 2D graphic group is interested in OpenJFX, which is the JavaFX project, because this belongs to 2D graphics and front ends. So this is a group that contributes to the OpenJFX project. It's not the only group. This is just an example to understand it. And next to these groups and projects, you can find on the OpenJDK so-called JEPs and releases. And a JEP is, you can think about it like a definition of a feature, so it's a kind of epic. And a release in the OpenJDK always contains several of those JEPs. JEP is stands for JDK Enhancement Proposal. And you can find both online. I've just put here an example URL for JEP 395. and an example URL for the release 16 of the OpenJDK. And when you go to those, for the releases, you find a page like this. So this is the release page of Java 13. And what you can see here in the feature sections are the JEPs that were implemented, so the epics that were implemented in Java 13 and a part of Java 13. And if you go to such a JEP, you find the whole definition of this functionality in general with source code example, with edge cases and all these things. So if you ever thought about, okay, how does a Java magazine or a blogger know about this all new Java features? In general, you only need to read these JEPs to understand the new language features and the new APIs that are part of Java, because all this is defined in these JEPs and really quite good documented in the JEP. So this is really the technical documentation of the features that are part of Java. So this is what you can find on the page as information. And next to this, we have the sources that happily, since Java 16, are hosted at GitHub, which makes the contribution to the OpenJDK much easier. And since this is open source, in general, everybody can contribute. I mean, yeah, it's more complex to contribute to the OpenJDK than to a small library or something. But in general, especially since it's at GitHub, you have the common workflows that you have in GitHub by using pull requests and things like that, that you can use to contribute to the OpenJDK. And while Oracle still does 75% of the contribution to the OpenJDK, the part of contributions that are coming from other companies or really individuals is growing. Especially the part of individuals has been grown with the move to GitHub. So there are a lot of people that did their first contributions to the OpenJDK by providing new features, by providing additional documentations and things like that. And I really know some people from, for example, the German Java community that did contributions within the last months, where you can really see that even as a private person, as an individual, you can contribute to the OpenJDK and the Java language and runtime. And when talking about companies that contribute, I have some samples. So here you see the companies that have contributed to Java 11. So to everything that happens after the release of Java 10 until the release of Java 11. And here you can see that, yeah, Oracle does the most, but there are quite a few additional companies like Red Hat or Bellsoft or Azure that contributed to Java 11. Here we see the same for Java 16. The good thing is when you have a look at all the different contributions, I don't want to show all here, you can see that the number of companies is growing, and some important and big companies have started to contribute to the OpenJDK within the last years. One good example is Oracle, for example. Another one is Amazon, who both started to build up a Java team in the company and started to really work on the OpenJDK and contribute to the OpenJDK. Between Java 11 and Java 17, those are the companies next to Oracle that have contributed to the OpenJDK. And I think this is, yeah, I don't know how much, maybe 20 or something like that, which is quite a good number. So to be fair, some of them do it because they have their own runtime, like Microsoft, for example, has in some months, or Azure or Bellsoft or Amazon, others, or SAP, for example, some others like Huawei, contributed because they want to have Java, or Microdoc want to have Java used on their hardware. So ARM, for example, wants to run Java good on ARM CPUs, as an example. Same for Intel. But as said, some of them have Java distributions. So here are just some of the big ones that are out there and have been established within the last years, like Amazon Pareto, Bellsoft Liberica, or Azure Zulu, or Tamarin from Adoptium. And one special thing that most of those Java distributions have in common, and this is a part of the OpenJDK or something that is related to the OpenJDK that is not open source, which is the Java TCK, the Java Test Compatibility Kit. That is a kind of test suite that you can use against a Java binary to test that Java binary and check that the binary supports the Java SE standard. Once this TCK has run against or successfully run against a Java binary, you are allowed to say that this is a Java compatible binary. Without having that TCK one, you are not even allowed to name it like that, because Oracle owns the Java trademark. And yeah, as long as you have a TCK, you are allowed to call it Java compatible. Otherwise, the lawyers from Oracle will ring at your door. And this is really closed source, the test compatibility kit. And yeah, you need to sign an agreement with Oracle that you are not talking about the content of this TCK, that you do not share any information regarding the content of this TCK, you do not share any information how this is working, and so on. So this is where Oracle still makes, or where Oracle, this is one point where Oracle makes money with Java by having this closed source TCK that people need to sign the contract and pay money to have the TCK working and running against your system to name your system a compatible Java runtime. And there are quite a lot of companies that have signed this agreement. Here you can see again all those companies that provide Java runtimes like Azure, Bellsoft, Microsoft, Amazon, and so on. Okay, these are just some insights regarding the OpenJDK and what is all part of the OpenJDK next to the word Java sources. Let's have a look at the Java roadmap. So what we've already seen so far is that the Java versions are defined in the OpenJDK. You have a web page for each version with the JEPs. So the OpenJDK in general defines when a tag will be created, so when a new version comes out. How long such a version will be supported, and if I as a vendor even build a binary based on this version, is totally up to me. When talking about Oracle, for example, here you can see what Oracle did. So in the past, like Java 7 and 6 and so on, it was quite easy because the Oracle JDK builds were totally free and you were allowed to use it even in production. But in 2019, Oracle has changed their licenses. And since Java 11, you are not allowed anymore to use the Oracle JDK binaries in production. And the Java 8 and 11 versions only, you only get updates when you have a commercial LTS. You get downloads for 11, 12, 13, and so on for half a year, but you're not allowed to use it in production unless you pay for Oracle. Other companies have much better or less constraints here. If you, for example, use Amazon Pareto, Azure Zulu, Adoptium Tamarin, and so on, you in general can use it in production for free, and you normally get LTS versions for free. So what an LTS version is not defined by the OpenJDK. This again is defined by the vendor. So in theory, if I would be a Java vendor, I could set up LTS support for each Java version for as many years as I want, because I need to take care about that. In the past, it was common that, yeah, after Java 8, there's a new LTS release all 3 years, which happens with Java 11, with Java 17, that was released now. And now, in the moment where everyone knows it, it's totally clear that the next one will be Java 33, right? Because this is the version in 3 years. And since it was quite hard to get this message to the Java community and make the Java community understand this new model, now Oracle decided that it don't make sense anymore and changed it again. So last month, Oracle just said that their new next Java LTS release will not Java 23, but will be Java 21. And based on this, there was a big discussion on the OpenJDK mailing list. And since a week or so, all the big companies like Azure, like Microsoft, and so on, all accepted that they will take care of this too. So the next common Java LTS release will really be Java 21 in 2 years. And the idea is to then have LTS releases all 2 years. Next to this, Oracle changed their license again. So since we learned with Java 11, okay, we are not allowed to use Oracle in production because it's not free. Now you can download Oracle Java 17 and it's free to use in production. So again, you need to learn something new. And when you learn that, you should definitely learn that this is just a trick, because it's only free in production until a short amount of time, because in 2 years or in 3 years, Oracle will change the license of JDK 17, and then you need to pay for it. Yeah. So maybe you better use, I don't know, another one time or pay support. So if you don't want to pay support, maybe you should not use Oracle. So as mentioned, I would like to talk about new features that happened in the last versions of Java. So I don't want to show all. This would take way too long. But as already mentioned, we have these releases in the OpenJDK and therefore the JEPs. So what we want to do now is have a look at the JEPs that are part of the last Java releases. When talking about JEPs, it's quite useful to know some generic JEPs. One JEP, or an interesting JEP, is JEP 0. So if you go to the URL of JEP 0, you see a list of all JEPs. So JEP 0 is the JEP index. This is historical. I don't know if it was not possible to create an index page in 2006, no idea. But this is really how it works. Then you have some JEPs that define the workflow of the JEP and the release process of the JDK. This is only interesting if you really want to contribute to the OpenJDK. If you want to have a look at new features, two other JEPs are much more interesting, and they are new. So they started to introduce those JEPs with the new release train. And this is the JEP for the previews and the JEP for the incubator. And the incubator mode allows the developers of the OpenJDK to provide new features in a Java release in an incubator state. There's a JDK.incubator package, and everything that is in this package might change in future. While it's public API, this is an incubator, and it will be moved to, I don't know, java.something in a later version, but you can already use it and play with it. And this is normally used for new APIs that are added to Java. So this happened, for example, for the new REST client or HTTP client that has been introduced in Java 9. This was in JEP, in incubator mode in Java 9 and 10, and is an official feature under java.star since Java 11. Currently, in the OpenJDK, they started to work on a simple HTTP server API that will be part of Java SE. And I assume this will be in incubator mode too. The preview mode is more for language features, things like lambdas, text blocks, records that are quite new now, which is not defined by API. And this is developed in a kind of preview mode. And The Java runtime and the Java compiler have a new flag, which is called enable preview. And when you use that flag, you can even in older versions use preview functionalities of future Java versions. This is quite nice, maybe not in production, but it might make sense in tests. So this allows you, for example, or this enabled people that updated all 6 months already with Java, I think 13 use text blocks in text, even if they were introduced finally in Java 16. When having a look at the count of JEPs in a release, you can see that on the left, it's quite higher numbers. This don't mean that the count of new functionalities went down. This is because of the new release model, right? Because now we have a new release all 6 months. Earlier, we had a new release all 3 to 4 years. So the count of JEPs and new features has been increased in reality, because now we have all 6 months kind of 10 to 50 new features, which is really good. So let's have a look at all these features that happened after Java 11. I just have a list of the JEPs that are integrated into the releases. As said, we don't want to look at all of them, but you can easily go to the JEP pages and have a look at the documentation if you are interested in a specific feature. So these are the ones for JDK 12. Oops, sorry. Here we see JDK 13, and here we see the quite high amount of new features that has been added to JDK 14. And what you can see here, for example, is that several of the features, like the second one, the packaging tool, is defined as incubator. So this was introduced in incubator, and later you can see that the records functionality has been introduced as a preview JEP. So this, to use this already in Java 14, you had to use this enable preview features flag. A quite nice new feature that has been introduced in Java 14 and therefore is part of Java 17 too, and this is one of the best features in Java 17 from my point of view, are the helpful null pointer exception. So when a null pointer exception is thrown, you now see exactly what is null without needing to do something. So in the last years, I always did this objects.require null to check fields. And now if a null pointer exception happen at runtime, you can really see like, okay, we have here an exception because the field name is null, or even better, if you see it in the bottom, because so we cannot read a field, I don't know, name, because user or because office.user is null, and therefore we cannot do office.user.name or something like that. That is really, really helpful, and without changing anything, you will have with Java 17 directly this feature. Another really good feature that finally has been introduced in Java 15 was as a preview feature in all the earlier versions are text blocks that allow you to now write something like this in Java. So you can write multi-line strings and even use formatting in those strings, like you can see here in the HTML that is already formatted. Again, how all this is working and how the formatting rules are and how escaping is working in those strings and so on. This can all be seen in the JEP. Java 16, here a lot of ports, and at the end we can see this migrate from macro to Git and migrate to GitHub. So these are, here you can see that a JEP must not be a new functionality to the runtime or classes of Java, but it can be even an improvement to the OpenJDK, because this really defines the migration of the sources from the OpenJDK to GitHub and the support of the standard GitHub flows like pull requests. Another nice thing is the Windows ARC64 port that allows to run the OpenJDK based builds on ARM architecture on Windows. We will see later that it's the same happened for Mac too. Another thing that is happening here is the vector API that has been added to Java 16. And this is something that really helps you in performance. I don't want to go deep into that because I assume for the vector API, only for this one, a full talk is needed to understand it. And to be fair, I'm not deep enough into that one right now to really give you details. But in general, you can think about the support of low-level vector operations. So when you, in the past, for a vector operation, as you can see it on the right, needed 4 duplications, additions, and assignments. So several steps with the vector API and the so-called single instruction multiple data support. You can now do this with just 1 multiplication, 1 addition, and 1 assignment. So you have much less steps on the CPU to do such calculations. And yeah, especially in things like 3D rendering or other things where you work a lot with vectors, it's much, much faster to use Java now. And finally, we have JDK 17, which is a new LTS. Here again, we have several new APIs. And here you can see that it's not always adding things, but maybe even removing things or deprecating things. So on the right side, you can see that the security manager has been deprecated. The applet API has been deprecated for removal, which means it will be removed in the future Java version. And below that, you can see that functionality has been removed. So the in Java written JIT compiler has been removed and some other things too. A quite nice thing is the last one, the 391. This is the ARM support for macOS, and with that one you can use OpenJDK builds done directly on this M1 processors for macOS. Another thing that has changed is the new macOS rendering pipeline. It's in the middle on the left, it's 382. Since in the past, Apple used OpenGL for rendering, it has been introduced something new, which is called the Apple Metal API. So like DirectX on Windows, Apple now has its own API or layer for graphics things and things like that. And with Java 17 now, OpenJDK works against that layer, which makes graphic support on Mac much faster. So the old OpenJDK API and the integration of that API in the OpenJDK still exists, but now we have this new Metal API, and as I already mentioned, we have the support for ARM processors on the Mac. So we don't need to use Rosetta anymore to run Java applications on an ARM-based Mac. Okay, so far regarding new features, as mentioned, I would like to have a look at the different distributions that are out there on the market. And especially one distribution that I would like to mention is Adoptium. If you have not heard about Adoptium so far, Adoptium is the successor of Adopt OpenJDK, which is one of the mostly used, in several cases, the mostly used OpenJDK build out there. The project has been grown so fast and that we as a community decided to join a foundation, and therefore the Adopt OpenJDK project has been migrated to the Eclipse Foundation and become Eclipse Adoptium as a top-level project at the Eclipse Foundation. And happily, a lot of leaders of the Java ecosystem are part of the Adoptium working group and together work on free Java binaries, free Java tooling, and a free and open Java ecosystem. I'm quite happy to be part of the working group and steering committee too, by being there with Karakun, next to companies like Microsoft, Red Hat, IBM, and so on. Like others, we at Adoptium provide an OpenJDK distribution too. And the distribution that Eclipse Adoptium provides is called Tamarin. So some of you that already used Adopt OpenJDK and the Adopt OpenJDK distribution in the past might ask yourself, okay, but wait, so why is it not called just Eclipse Adopt OpenJDK? So the answer is quite easy, because it's not allowed. So OpenJDK and Java are both, as I already mentioned, trademarked by Oracle, and since the Eclipse Foundation trademarks all their project names for top level and sub projects, it was just not able to use Adopt OpenJDK because this is not trademark able with OpenJDK in the name. So for a lawyer, this is how it is, right? And here you see all the different trademarks and things between the companies and the names and so on. So this makes really at the end make it quite complex. But this is why we ended with the name Adoptium as the top level project. And then Tamarin as our binaries. And now, if you again come from Adopt OpenJDK, where the project name and the binary name was the same, you might ask yourself, okay, but why is not Eclipse Adoptium building Adoptium binaries? At the end, we're just convenient now and do what all others do too, like Azure systems that provide Zulu, or Amazon that provides Coretto, or Bellsoft that provides Iberica. We at Adoptium now provide Tamarin. So you have a vendor name and a product name. The product is always the runtime. If you have not heard about Tamarin that far, so that's the Java runtime you should use. And if you ask yourself where the name is coming from, so this is quite nice because there are 2 points that might help you to do not forget the name. So first of all, it's this one. So Tamarin is an anagram of runtime, which makes it quite good for an OpenJDK-based runtime. And the other one that I, to be true, like even much more is that Tamarin is the chemical element that is the element that is, or the element that is as the next one next to coffee. So Tamarin is quite similar to the chemical element, I don't know how to call it, that coffee is. And I mean, Java coffee is everywhere, and so Tamarin is the perfect name for this one. Another point why we've named our binaries differently than the top level project Adoptium is that next to Tamarin, we have even more things that happen at Adoptium. Another thing that I can share with you today is AQAvit, which is an open source test suite for Java binaries. So we've seen earlier that Oracle has this closed sourced Java TCK that you can use to test your Java binaries and then be certified Java compatible or Java SE compatible runtime. And AQAvit is quite similar because this helps you to test your Java runtime and check that your Java runtime is enterprise ready and rock solid. So at the end, it's a test suite for Java SE runtime and therefore for OpenJDK based builds with a lot of tests. And when we build Tamarin, for example, this AQAvit test suite is executed. And since Tamarin is built for different operation systems and platforms and architectures like Intel Mac, ARM-based Mac, Linux, Windows 32, 64, and so on and so on and so on. And we provide different versions of OpenJDK like 8, 11, 17, and so on. at the end, we run a lot of tests with this AQAvit test suite for each release. To be true, it's about 87 million tests that are executed with each release of Xamarin to check that Xamarin is really enterprise ready. The test suite contains different kind of tests. So all tests are separated in some groups. So first of all, we have this OpenJDK group that contains tests that are part of the OpenJDK. So all OpenJDK tests are executed. Next to this, we have some functional and system tests. Those were contributed by IBM. And we have some benchmarks, like you will see in the bottom, that not even checks the functionality of the runtime, but even checks the performance of the runtime, checks that the runtime behaves as performant as it should be. And next to this, we have around 125,000 additional tests that come from external projects. Because what we are doing is we run tests, unit tests, and integration tests from external projects against the runtime. For example, we run different TCKs from Eclipse Microprofile and Jakarta EE. This is done like that. So when the runtime should be tested, a container, for example, a Docker container is set up. Some old tests still use Ansible and things like that. But to make it easy, we just now think about a Docker container. And then the JDK that has been built that should be tested is copied into this Docker container. And next to this, some tools that we need for the tests are copied into this Docker container. And tests that we are run, for example, are the tests from Derby, which is this open source Java-based database. So we check out a tag from the Derby repository and then build Derby and run all Derby tests by using our JDK build. And by doing so, we check that Derby and the tests of Derby are running with our OpenJ build just perfectly fine. And all this is happening against the runtime that should be tested to check that all these enterprise things, we have Tomcat, for example, we have this microprofile, TCKs, and so on, are working fine on the binary that is tested. And this is already used by several other distributions too. Azure, for example, uses AQAvit 2 to test all the binaries. And we again use it at Xamarin, which makes Xamarin quite special because it's not only special since it's not coming from a company as a vendor, but it's coming from a foundation and the community. So it's the only vendor neutral build of the OpenJDK out there. Next to this, it's the most open build of the OpenJDK. Because next to the OpenJDK sources that we use, we have open sourced the installer sources for Xamarin. So for example, for the Windows, graphical Windows installers and things like that. We have build scripts that we use that are completely open source. Everything is executed on a build server that is open. So you can have a look at the Xamarin build server and have a look how Xamarin is built and see into the logs and the configuration and so on. And the AQAvit tests are completely open. The only thing that sadly needs to be closed is the TCK check, so the Java TCK that comes from Oracle. That happens on closed servers because we are just not allowed to do it in the open. And even the binaries that we create are hosted at GitHub. So even at adoptium.net, so when you download a binary, this is just forwarded to GitHub because this is where our binaries are stored. So this is what currently happens at Adoptium. And as mentioned, there are a lot of other distributions that have difference, right? Some create distributions like Amazon because they want to have their Java versions used in their cloud. Some like Azure wants to sell LTS supports, and based on that, they create distributions. Others like Red Hat, who have enterprise Linux and enterprise application server support, just bundle their Java binaries with their other products to have a quite good bundle and have everything in their control. And based on this, the market is quite distributed of OpenJDK-based builds and runtimes that are out there. And this is a point where Adoptium is currently working on some quite good solutions too. Because next to the TCK, we have AQAvit, and what we are currently working on is providing a marketplace, so a vendor-neutral marketplace under the Eclipse Foundation, where all the binaries that are TCK and AQAvit approved are listed and are ready to download. So this is just a mock-up that I've created for the marketplace with an example of binaries coming from Azure, Microsoft, and Adoptium. But as said, the plan is to really include all the binaries that are enterprise ready because they passed all the tests that are out there, which is the TCK and AQAvit, should be listed here and then are ready to download. And once we have that, I hope the distribution of the OpenJDK and OpenJDK binaries becomes again much easier to understand for Java developers and end users that just want to download Java. Okay, that is what we do at Adoptium. At the end, I have some slides since now Java 17 is out that might help you to migrate your application to Java 17 or to, in general, a newer Java version. First of all, there is some documentation. Oracle, for example, has provided a migration guide for Java 17 that helps you to upgrade to this version. In general, when you download it, what you ever should do is just download Java 17, check if your application or your code compiles with Java 17, upgrade your third-party libraries, check if they are compatible, and at the end you can run JDEPs to get an information about the dependencies of your code and if everything depends quite nice on Java 17. One thing you need to keep in mind, especially when you come from Java 8, are the evil private APIs of Java. So everything that is not under java.star or javax.star, like this some unsafe classes and so on. So you might have used such classes in your Java application in the past, for example, when you used Java 8. With newer versions of Java, this is not possible anymore because in Java 17, JEP was introduced, which is the strongly encapsulation JDK internals. And this do not allow you to use Z APIs anymore. So when you used such APIs in the past, so before Java 9, it was just okay to use it. With Java 9, this illegal access flag has been introduced that let you crash your compiler when you use such APIs. The default was that you see a warning in the command line when you use such an API. With Java 16, this switched to the default value of deny, which means like, so when you compile a Java application that uses internal APIs, the build just breaks. And the problem is, or from my point of view, it's not a problem. The point that you need to have in mind is that with Java 17, things like warn, permit, and debug, all these options are disabled now. So by default, if you use it now, you cannot use such internal APIs anymore. You can still use this at opens option or at opens in the manifest to access specific points, but just compiling everything as it is by using private APIs from the OpenJDK is not allowed anymore. Next to this, within the last years, the handling of deprecation has been changed. So from Java 1 to Java 7, things have been deprecated and nobody cared, right? Because Java, things that are in Java are there forever. And this has been changed because with Java 9, a new attribute has been added to the @deprecated annotation, which is for removal. And an API of the OpenJDK that is now deprecated and has this for removal equals true attribute set. This API can be removed in future. And since we now have a release train with new Java releases each 6 months, this means that even 6 months after it has been deprecated and marked for removal, it could have been removed from the OpenJDK. And this really happens. So at least with Java, between Java 8 and Java 11, several things like Corba, JAXB, and Java Enterprise annotations have been removed from the OpenJDK. And between Java 11 and Java 17, more things have been removed. So it's not only that there is a new attribute, this attribute is really used. You can easily check the differences by using the Java version almanac, which is an open source tool that is developed by Mark Hoffman. And this tool allows you to display a diff between 2 Java versions. So you can, for example, say, okay, I have Java 8 and Java 17, and ROS has been changed. And this tool then really shows you all the Java APIs that has been changed by showing classes, methods, and so on that has been added, that has been removed, or that has been deprecated. And by doing so, you have a quite good overview about the changes that has been done between 2 Java versions. And whenever you do an update, this is quite good to have a look at it, to see what is new, and maybe have a look at it to understand it and use it in future, and to see what has been removed and check, do I use it, or maybe does one of my dependencies use it? Okay, so these are just some helpful tools and tips when doing updates to a next Java version. I hope there were some new parts for you regarding OpenJDK, Adoptium, or Java 17 in this presentation. Yeah, thanks for listening to the presentation. Stay safe and healthy. And if you have any questions, you can easily ping me, for example, on Twitter with @Hendrik Ebbers, or you can just find us at karakun.com or at devkarakun.com, which is our developer-friendly page with some infos regarding Java, blog posts regarding Java, and even recordings of our sessions like this one. If you have questions about OpenJDK, Adoptium, just ping me. If you want to have a workshop or consultancy in this direction, yeah, please ping me too. I would be more than happy to help you. Okay, so thanks for listening. See you at the next session or conference.